Hi students, welcome to our chemistry class. Our chapter name is Acid, Base and Salt. In the last class we introduced this chapter and the last topic was indicators. We discussed about different types of indicators yesterday. We discussed about natural indicators and synthetic indicators. Also we discussed about olfactory indicators. Now we are going to discuss the further topics in this chapter. The first topic today we are going to learn is the reaction of acid with metal. Reaction of acid with metal. For this, we want one experimental setup. That means, I am clamping one test tube on a stand and then connecting one tube here. It is then arranged in a beaker which is filled with soap solution. That is, this tube is under this soap solution. Soap solution. And in this test tube, I am taking H2SO4. That is the sulfuric acid. And also I am adding some zinc granules. I am adding some zinc granules means zinc pieces. So this is the experimental setup. And after some time you can see that here bubbles are getting formed. And this, what is the meaning of these bubbles? These bubbles are meaning that here certain type of gas is formed. So that gas is just move through here and will reach in this soap solution. And after some time you can see that soap bubbles are forming from this. That is the aim here. We are just giving this tube to this soap solution. That means they produce a type of gas. Now we want to identify which is the gas here produced. We want to identify which is the gas produced here, and in laboratory we are using, just put one burning matchstick here. And when we put the burning matchstick here, you hear a sound, and that sound is pop sound. The gas which produces this pop sound is hydrogen gas. Hydrogen gas. That means when this acid is getting reacted with metal, they produce a gas, and that gas is what? Hydrogen gas. So, in generally for all the experiments, we are using this burnt matchstick to identify the presence of hydrogen gas, or you can use a burning candle. Then also you can hear this pop sound. So this is the experimental setup. Now we are going to study the general equation that here happens. And also one thing, that the general equation is like this. When the acid is getting reacted with metal, the product is this salt and hydrogen gas. So these are the products that we get when this acid is getting reacted with metal. Actually, the thing happens here is this: when we are just taking acid here, H2SO4, any type of acid, and we are just putting zinc granules. That means metal inside this acid. Then what happens is that the hydrogen gas inside this acid, acid is escaped or displaced by this metal. This metal displaces the hydrogen gas inside this, and then what happens is that this metal is getting mixed with this. The further thing remain here and then form a salt. Salt means a metal salt. A metal salt is formed here. This is the thing happens when acid and metal react together. That means simply we can say it as when this metal is getting react with this acid, hydrogen gas is escaped and a metal salt formed. This is the thing here. Now we are going to study the equations for some type of reaction. The first one is the reaction of zinc and sulfuric acid. Zn plus H2SO4, that is the reaction between sulfuric acid and zinc. The products are this ZnSO4 plus H2. ZnSO4 plus H2. H2 means our hydrogen gas, and this ZnSO4 is zinc sulfate. Zinc sulfate. This zinc sulfate is what? The zinc sulfate is the salt. This is the salt and the hydrogen gas formed when the zinc is getting reacted with the acid, sulfuric acid. This is the equation for the sulfuric acid. Now we are going to study the reaction with the hydrochloric acid. The same zinc is getting reacted with hydrochloric acid means HCl. Then the reaction is like this. ZnCl2 plus H2. This is the reaction, but now it is not balanced. I will balance it. So, when the zinc is getting reacted with hydrochloric acid, we get the product zinc chloride. Here, zinc chloride is the salt and also the hydrogen gas. When you observe this equation, Zn plus HCl gives ZnCl2 plus H2. Here, when you observe, this chlorine is of 2, but here only 1. So, we are just adding 2 here and then the equation is balanced. So, the balanced equation is Zn plus 2 HCl gives ZnCl2 plus H2. So, this is the reaction of hydrochloric acid with zinc. This is the second example. This is the first example and this is the second example. Now we are going to discuss the next example. That is the reaction with the nitric acid. The same thing is here. Then zinc is getting reacted with 2HNO3. Then the product is this ZnNO3 twice plus H2. This is the equation for the nitric acid and the reaction of zinc. When Zn plus 2HNO3, that is the Zn is getting reacted with this acid, then we get one salt. And what is the name of this salt is zinc nitrate. Zinc nitrate and hydrogen gas. This is the third example. And the fourth example is the reaction of zinc with acetic acid. Acetic acid, that is CH3COOH. This is what? The acetic acid. So, the equation is this Zn CH3COO twice plus H2. When you observe this equation is unbalanced and we can make it balanced by adding 2 here. So, the equation is like this. When zinc is getting react with acetic acid to CH3COOH. Then the product is like this, Zn CH3COO twice plus H2. And what is name of this Zn CH3COO twice? It is zinc acetate. Zinc acetate. This is the zinc acetate. So these are the examples you want to study. You want to study the reactions and also want to know the name of this salt. And other product is hydrogen. So this is all about the reaction of acid with metal. The next is the reaction of metal and base. Here we discussed about the acid and metal. Now we are going to discuss about the base with metal, the reaction. Reaction of metal and base. Here I am selecting the base sodium hydroxide. Here I am selecting the sodium hydroxide. For this experiment, I am just taking one test tube which is filled with sodium hydroxide and I am putting some zinc granules here. And again, after some time you can see that bubbles start forming here. And when you again place one burning matchstick here, you can hear the pop sound here. That means here also the gas form is what? Hydrogen gas. Hydrogen gas. So we can say that when the metal and the base is getting react, here also salt and hydrogen gas is formed. Now we are going to write the general equation for this. That means when the base is getting react with metal, then we can write the general equation as we get salt plus hydrogen gas. But one problem is this, we don't get the salt and hydrogen gas for all the metals. This is only for certain type of metals. So when you write the general equation, you want to write at the bottom, not occurs with all metals. That is the difference with this acid and the base for the reaction. That means for the acid, that is generally for all the metals, therefore the salt and hydrogen gas. But when we are thinking about the base, for this zinc it forms. But for some sort of metals, it is unable to produce the salt and hydrogen gas. So you want to remember this. Not occurs with all the metals, this result. Now we are going to write the equation of the sodium hydroxide is getting react with zinc. That is the experiment we conducted. That means we just collected some sodium hydroxide and zinc in a test tube and we got certain type of gas and salt. What is the salt? The salt is Na2ZnO2. This is something new for you. Plus the hydrogen gas. And when you observe this, this equation is unbalanced and for balancing it we want a 2 here. So the equation is like this. 2NaOH plus zinc gives Na2ZnO2 plus H2. And now the question is, what is this? This is actually a type of salt and the name of that salt is sodium zincate. Sodium zincate. That is the name of this salt which form in the reaction with this base and the metal. So you want to remember the name and the chemical formula of this sodium zincate. That is Na2ZnO2. This is all about the reaction with the metal and base. Just want to remember, for some metals they form salt and hydrogen, and we want to study the equation of sodium hydroxide and zinc. Now we are moving to the next topic. That is the reaction with the metal carbonate and metal hydrogen carbonate with the acid. We are talking about the reaction with the acid. So, first question is, what is this metal carbonate and this metal hydrogen carbonate? These are two types of compounds, metal carbonate and metal hydrogen carbonate. Now, I will show you one example for this. NaCO3 and here NaHCO3. This is the example for metal carbonate. This is the metal and carbonate, and this is the metal hydrogen carbonate. This is the metal, this is the hydrogen, and this is the carbonate, metal hydrogen carbonate. So, this metal carbonate and metal hydrogen carbonate means nothing but a type of compound. Now we want to study the reaction of this metal carbonate and this metal hydrogen carbonate with acid. So for this we want some experimental setup. That is, I am taking two test tubes. And then in these two test tubes I am collecting dilute HCl. That means dilute hydrochloric acid. Then I am putting some sodium carbonate. Actually this sodium carbonate is something solid. So I am putting some sodium carbonate in this test tube A and this is the test tube B. So some sodium carbonate, that means NaCO3. Sodium carbonate in this, that is the metal carbonate. And in the test tube B, I am taking some sodium hydrogen carbonate, that is the metal hydrogen carbonate. So, metal hydrogen carbonate there. So, I am just taking one acid and this metal carbonate and acid and metal hydrogen carbonate. Now, the experimental setup is not over. We are just closing this with some cork and then again connecting one tube here. The aim is to collect the gas here forms. So, we are just taking this tube to another beaker. Again we are connecting this to another beaker, and this beaker is having some sort of thing. And what is this? The beaker contains calcium hydroxide. In the both beakers, here also it is calcium hydroxide. This calcium hydroxide means the lime water. So that means we are getting ready with the experimental setup. So after some time, again you can see that here bubbles form, and that means they produce certain type of gas, and that gas is moving through this tube and reach to this lime water. At the initial stage, it is having some sort of transparent color, and after this experiment, that means after some time, you can see that the color of the solution is getting milky. That means the meaning is this, they produce certain type of precipitate. That's why it becomes milky color. The same thing happens here also. You can see bubbles there forms, and that bubbles. That means the air is traveling through this tube and finally reaching this beaker. That means the lime water, and also you can see the milky color, and that means therefore certain white precipitate in this beaker also. Now the question is, which is the gas that forms here? The gas here forms is what? Our carbon dioxide. Now we are going to explain this equation. That means we are going to explain the reaction with this. This is only the experimental setup. Now we are going to explain the equation. First, with the metal carbonate, that is the sodium carbonate. Then the sodium carbonate Na2CO3, which is solid, Na2CO3 solid, is getting react with acid 2HCl, that is in aqueous form, and we get the product as 2NaCl, that is in aqueous form, plus H2O, that is in liquid form, plus CO2, carbon dioxide. So when a metal carbonate and acid is getting to react together, we get the gas carbon dioxide. So that is the gas that made the lime water milky. And also you can see here, this NaCl is a type of salt, and also in this reaction water is formed. This is the reaction for the metal carbonate, that is the sodium carbonate is getting reacted with hydrochloric acid, we get sodium chloride. This is sodium chloride, 2NaCl plus H2O, water plus carbon dioxide gas. This is the reaction with metal carbonate. Now we want to check the equation for the metal hydrogen carbonate, that is NaHCO3, which is in solid state, is getting react with hydrochloric acid, which is in aqueous form. Then you get the result as NaCl, which is in aqueous form, plus H2O, that is in liquid form, plus CO2, that is in gaseous state. So here the only difference is this. The result is same. It forms sodium chloride, water, and the carbon dioxide. So that means here only the difference is with this and this. That means the number of molecules are getting only different. That means the metal carbonate and the metal hydrogen carbonate, when it is getting reacted with acid, same products we get. That is, we get a certain type of salt plus water plus carbon dioxide gas. Here also you can see a salt is formed, water is here, and gas is carbon dioxide. Now, this is the thing. This is the general equation. I will write the general equation how we can represent for the metal carbonate and for the metal hydrogen carbonate. But now we want to study two equations extra. That is, in the experimental setup, first we collected the gas and then we connected that gas with the lime water. Now we want to write the equation with this gas, that is the carbon dioxide gas, and the lime water. That we are going to write. The next equation. The equation is like this. CaOH twice. CaOH twice. That means the calcium hydroxide is getting, this is in aqueous form. The calcium hydroxide is getting react with carbon dioxide gas. What products we get? We get the product as CaCO3, that is in solid state, plus H2O in liquid state. That means this calcium carbonate, CaCO3 means calcium carbonate. Calcium carbonate. This CaCO3 is the calcium carbonate. So here form calcium carbonate and also the water. This is the white precipitate that you can see in the beaker that forms when this carbon dioxide is getting react with this calcium hydroxide. Calcium hydroxide means lime water. So when this carbon dioxide is getting react with this calcium hydroxide, you get white precipitate and that is called calcium carbonate, CaCO3. That is in solid state and also therefore water. And when we are keeping this for a long time, then what happens is that this calcium carbonate again get react with carbon dioxide and therefore another product. Now we are going to write that equation. That means when excess amount of carbon dioxide is again and again coming to this beaker, then what happens? That the equation is like this. CaCO3, the product calcium carbonate in the solid state is getting react with we have water is here, H2O, that is in liquid state, and again carbon dioxide is getting react with this CO2, that is in gaseous state. Then we get another product and that is CaHCO3 twice, that is in aqueous form. CaHCO3 twice. And what is the name of that? The name is this calcium hydrogen carbonate. Calcium hydrogen carbonate. Calcium hydrogen carbonate. That is the final product that will be there in the beaker. That means at the first, when this metal carbonate is getting react with what? Acid. Therefore, carbon dioxide is there, water is there and a salt is there. Then we collected the carbon dioxide gas and passed it through calcium hydroxide. Then therefore, another precipitate and that is what? Calcium carbonate. And also they produce water. Then again continuously this carbon dioxide is passing through this. Then what happens? Therefore, this product CaHCO3 twice and that is what? Calcium hydrogen carbonate. Or for this another name is that is calcium bicarbonate. Calcium bicarbonate. You can call either the names. Calcium bicarbonate. Calcium bicarbonate. Two carbonate. That is this calcium bicarbonate. So this is all about this. And actually these all are different types of calcium carbonates. We are talking all about this calcium carbonate. This is what? Calcium hydrogen carbonate. That means for this calcium it is having different forms of calcium carbonate. So actually when we are talking about the limestone, chalk, marble, these all are having very different physical properties. Actually these all are what? Different forms of calcium carbonate. So we are going to conclude this, that when the metal carbonate and the metal hydroxide is getting react together, when they react together, when this metal carbonate or metal hydrogen carbonate is getting react, either of this is getting react with acid, we get the result as salt is there, carbon dioxide gas is there, and water is there. So this is the general equation for this. So this is all about this area, and you want to study the equations in this region. Now this topic is over. Now we are going to discuss the reaction of acid and base. Acid and base. That means what happens when this acid and base react together. We already discussed some of the things in the last class also. The same thing is here, that I am just taking one test tube and taking some sodium hydroxide in this test tube. That means I am just taking a base here and adding some phenolphthalein in this, and I am adding some phenolphthalein in this. Phenolphthalein in this. Now what is the color of this? When the phenolphthalein is added to the base, what is the color of this solution? The color is in pink. And for the acid, it will be colorless. Now, I am going to do that. Just take some hydrochloric acid and going to add to this drop by drop. That is, I am just taking some hydrochloric acid and adding to this drop by drop and shaking this. After some time, you can see that the pink color is getting disappear. The pink color is getting disappear. What is the meaning of this? When this pink color is getting disappear means the effect of the base is getting nullified. The effect of the base is nullified by acid. The process of this nullify is actually what? The neutralization. Neutralization. So, here now this solution is in colorless. No pink color is there. When we are adding this drop by drop, the color will get into pale, pale, light and light. At a particular time, you can see that there is no pink color is there. And now I am doing that. Now this is in transparent color. There is no pink color. Now I am going to add drop by drop this sodium hydroxide. So when we are again adding drop by drop, what happens? Here again the color pink will come. That means once we did that, it gets nullified the effect of sodium hydroxide. When we are again adding this, what happens? It will show the property of base. So this is the experiment which shows the effect of the reaction between the acid and base. That means when they are getting nullified, there is no effect with this acid and base will be there. It is getting cancel each other. We will simply say it like that. So this is the experimental setup. Now we want to study the general equation for this, and also we want to study the equation, the chemical formula for this using the hydrochloric acid and sodium hydroxide. In the reaction of acid and base, the general equation is like this. When the base and acid are reacting together, we get the product as salt and water. This is actually what? Neutralization. And here also produces heat. Heat is evolving. Now we are going to write the equation for this NaOH, that is in aqueous form. Sodium hydroxide is getting reacted with sulfuric acid, that is also in aqueous form. Then we get the product as NaCl. This is the salt, NaCl, that is in aqueous form, plus H2O, that is in liquid state. So this is the equation for the sodium hydroxide and hydrochloric acid. When NaOH plus HCl get react together, we get the product as NaCl plus H2O. NaCl is a type of salt. What is the name of that salt? Sodium chloride. Sodium chloride plus water. This is about the reaction with the acid and base. And with all type of acid and base, the salt will be different, but it will get salt and water. This is all about the reaction with the acid and base. I think it's clear for you. Now we are moving to the next topic, that is the reaction of metallic oxide with acids. Reaction of metallic oxides with acids. What is this metallic oxides? You are already familiar with this metallic oxides. We discussed this metallic oxide in the chapter metals and non-metals. When we are reacting the metal with the oxygen, we get what? Metallic oxide. Now we are going to react these metal oxides with acid. That is, in a beaker, I am just taking copper oxide. That is, I am just collecting some of the copper oxide. Actually, in this experiment, we are taking copper 2 oxide. So, I am just collecting some copper oxide. That is, the initial stage, the copper oxide is having a black color, some sort of dark color. We can say it as black. It is black powder, solid state. So I am just collecting some copper oxide in a beaker, and now I am going to add HCl, that is dilute hydrochloric acid, drop by drop in this beaker. That means I am adding this drop by drop and just shaking it. I am adding this hydrochloric acid and shaking at the same time. What is the color of this dilute hydrochloric acid? Actually, the color is something transparent or similar to white. When we are increasing the concentration, it will be like something yellow. But generally we can say it is transparent and colorless. But when we are adding this to this and shaking, you can see that they produce the color green. That is, the colorless hydrochloric acid is getting into green color by reacting with this copper oxide. So, they form a particular type of salt, and that is copper chloride. And we will discuss the equation and all. Now, you just want to understand that when this copper oxide is getting reacted with acid, therefore salt, and also therefore water. That means the general equation we can write it as when metal oxide is getting reacted with acid, we get the product as salt plus water. And now observe, I will show you something interesting. Where we get this salt and water as product? what we studied in the neutralization. When the acid and base is getting react together, we get the salt and water. So, actually this metal oxide is something which is having the basic nature. So, the metal oxide is in basic nature and this base and acid is getting react together, and that's how therefore salt and water. This is the general equation. In this region you want to study first of all the general equation, and in your mind you have to put this metal oxide is in basic nature. So that is the first thing. Now we are going to write the equation for this experiment. The equation is like this. When the copper oxide CuO, actually copper 2 oxide, copper 2 oxide, you are familiar with this copper 2 oxide and all. So when this copper oxide is getting react with 2 hydrochloric acid, then you get the result as CuCl2 plus H2O. This CuCl2 means copper chloride. Copper chloride. This is a type of salt. Salt and water is formed when a metallic oxide and the acid is getting reacted. And also you want to remember this is a type of oxide in basic nature. Then the base and acid is getting react together, you get salt and water. This is the equation. You want to study this. CuO plus 2HCl gives CuCl2 plus H2O. This is the reaction. Now we want to study, this is the reaction with the metal oxides with acid. Now we want to study the reaction of non-metal oxides with base. That is the next topic. Very easy, simple thing. The reaction is like this. Here we are going to study the reaction of non-metallic oxide is getting react with base. Non-metallic oxide is getting react with base. Here also, now I am going to write the general equation. That means the experiment we already explained, and I will write the equation. Then you will identify which is that equation. So the general equation is this: when the base is getting react with non-metallic oxide, then you get the result as salt plus water. You get the result as salt plus water. Again, the same thing is here as the neutralization. The product is salt and water. That means this is the base and the non-metallic oxide is actually what? It is in acidic nature. Acidic nature. That means when a base and acid is getting react together, the products are what? Salt and water. So this is the thing, and here as an example you want to study the equation is this: CaOH twice is getting react with carbon dioxide gas, then we get it as CaCO3 plus H2O. This is the reaction you already studied in the last chapter. CaOH twice plus CO2 gas gives CaCO3 plus H2O. So, this is what? The CaOH twice is the base. And also, this is the acidic in nature. That's why they produce the salt and water. So we can say it as they produce salt and water. This CaCO3 is what? What is the name of that? Calcium carbonate. Calcium carbonate. So this is all about this. When this calcium hydroxide is getting reacted with carbon dioxide, then we get calcium carbonate plus water. So this is all about this equation. We discussed about different types of reaction with acid and base. So you want to study these all equations and also want to read your textbook, and we will meet in our next class with the further topics. It's enough for today. Thank you.